We like to simplify things in maths as much as we possibly can. So, for example, instead of writing 3 times 3, we write 3 to the power of 2. We can do this with 3 times 3 times 3 times 3 times 3 as well to make 3 to the power of 5. As long as the number is the same, we can do this for even larger numbers. So I'm not going to say that number out loud, but actually we'd write it as 3 to the power of 15 because there are 15 3's there multiplied together. So the 3 is called the base, and the 15, the number that goes up in the top right hand corner, is called the index or power. There are, well, let's say 6 rules that we have to learn in order to be able to use indices and powers correctly. You will use indices quite a lot, so we need to make sure that we can do the very simple things with them very easily. You need to know the simple rules for multiplying and dividing indices, and these are our first 2 rules. We know, we just looked at this one, a to the power of 5 is a times a times a times a times a, and that a to the power of 2 is a times a. So a to the power of 5 times a to the power of 2 must be those 2 things multiplied together. And that's 7 lots of a multiplied together, which, following the same thing we've done with a to the 5 and a to the 2, that's a to the 7. We can make a general rule here that a to the power of m times a to the power of n is equal to a to the power of m plus n. We add the indices. So to multiply together 2 numbers where the base is the same, we add the indices together. In a similar way, we can show that a to the power of m divided by a to the power of n is equal to a to the power of m minus n. So that's our first 2 rules that we need to remember about indices, multiplying and dividing. To multiply we add the indices, to divide we subtract them. Next rule is what happens with powers of powers. Here's an example, 4 to the power of 3 squared. Well, this is the same as 4 to the power of 3 times 4 to the power of 3. And we know that if we're multiplying numbers with indices, we add the indices together. So this becomes 4 to the power of 6. Again, we can generalize this to say a to the power of m to the power of n is the same as a to the power of m times n. So let's have a quick look at a reminder of our 3 rules so far. A to the power of m times a to the power of n equals a to the power of m plus n. If we do division, we subtract the indices, and if we do it to a power, so a to the m to the power of n, we multiply the indices together. 2 more rules. Simple one to remember first of all. Anything raised to the power of 0 is equal to 1. All the time. 10 to the power of 0 is 1, 100 to the power of 0 is 1, 1,000,000 to the power of 0 is 1. Then, what about if the index is a negative number? This isn't actually very difficult at all. We'll have a quick look at an example and then we'll show a very quick proof of this. So a to the minus 2, well, very simply that's equal to 1 over a squared. Let's quickly look at a proof of this. So a to the minus n, we can rewrite that using one of our previous rules as a to the 0 divided by a to the n, because 0 minus n is equal to minus n. This gives us a to the 0 over a to the n, and the rule that we just looked at above tells us that a to the 0 is equal to 1. So a to the minus n is equal to 1 over a to the n. Let's use this in an example. 7 times a to the minus 2. We don't usually write the times sign in there, but we're going to put that in there to make sure no one's confused. A to the minus 2 is the same as 1 over a squared. So our answer is 7 over a squared. A quick reminder here that of course 1 over a number we call the reciprocal of that number. Finally, we move on to our last rule. This is the one that people find most difficult to remember, and that is, simply put, a to the 1 over n is equal to the nth root of a. A to the 1 over n is equal to the nth root of a. Common ones. A to the half is the square root, because that's 1 over 2. A to the third is the cube root. More complex fractions also have meaning. So a to the 3 over 2 means the square root of a and raise it to the third power. So here's an example. 9 to the 3 over 2 is the square root of 9 raised to the third power. Well, the square root of 9 is 3. So 3 to the third power is 27. Numbers in this form, 9 to the 3 over 2, a to the 1/3, we call surds. Bit of a strange name, but it's one you'll get used to seeing. Surds. It's just another way of writing a number, and usually it's the most accurate way of writing a complicated number. In an exam question where you're asked to leave the answer in an exact form, you should always use a surd. So we've got 7 simple rules there. Most of them are fairly straightforward and common sense, and you'll be using them without even realizing them to be a rule of indices. Make sure you know them all and that you can use them very, very simply with all types of indices problems.